Hey, ChemStars, this is Mrs. Vandal. Bringing you the very first edition of the ChemStar video. Why is it called ChemStar video? Because you are the stars. Ha ha ha. Just a real quick intro to what we're doing here. Your notes, if you look through them, are divided into different sections, and each video only really deals with one objective. And you'll see those in the box. Here, let me show you what I'm talking about. So like right here, I'm on page 3 in your notes. So do you see this box here? So each video is going to deal with just one I can statement. And so the idea is that there's smaller chunks of videos and there will be objective checks for each one of these. So there will be an objective check just dealing with the section 1.2 plus 1. There will be an objective check for just 1.2.2. And so that way you can organize yourself. And, we're trying to break it down to smaller chunks to make it maybe more manageable for you guys so you can learn chemistry better. So anyway, let's begin. I want to go back to the front page again. And why am I here? Well, it's because I want to talk about the definition of chemistry again. We've already done these notes. You've already had demo day. We all love demo day, don't we? You get to blow things up and whatnot. And I want to revisit this definition of what is chemistry, okay? I'm going to revisit it quite a bit in Unit 1 here. But let's do it again. So chemistry is the study of the composition, structure, and properties of matter, and the processes that matter undergoes, and the energy changes that accompany these processes. All right, we're going to have really a section of notes that deals with this definition of chemistry. And before I really go much further, well, what is matter? Anything that has mass and occupies space. So again, we're going to talk about that, and really in 1.2.2, we're going to refer to what is matter again. So what are we going to do today? Well, on page 3, you're going to see we're at 1.2.1, and we're going to be talking about the composition, mostly a little bit of structure, but mostly the composition part of the definition. So let's go to page 3. So here we are. What is our objective for today then? We are going to, ready? I can identify atoms, elements, and compounds. Okay, so that is our goal for the day. So what's our vocabulary? Well, matter. Oh, anything that has mass and takes up space. Okay, that's good. Atoms, elements, and compounds. So that's our vocabulary for today. So let's start at the beginning. Atoms. Atoms are the building blocks of matter. They are the smallest unit of an element that maintains the chemical identity of that element. All right, so this is the building blocks. This is what all matter is made up of, are atoms, okay? And they can be arranged in different ways. So let's take a look at our examples here, okay? Here we have elements and compounds are made up of atoms. I'm reading right here as shown in these models. So the first one is a diamond. And what do you notice about our diamond? Every single atom is made up of carbon, all right? Did you know that? The diamonds that, are in your jewelry or somebody's jewelry anyway, the diamonds are just made up of carbon in a specific way, all right? And so that's the atoms of carbon there. But what about sugar? What do you notice about sugar? Do they have anything in common? Well, yes, they do. They both contain carbon. Here, carbons and diamonds and carbons and sugar, all right? But what else does sugar have? Sugar has hydrogens and sugar has oxygens, okay? And if you go back and look at what I underlined in the definition of matter, we're talking about the composition and the structure. Wouldn't you agree that these two have very different structures? All right, believe it or not, these are all the tetrahedral arrangement. Tetrahedral means four-sided. This looks more like a caterpillar, doesn't it? The hungry little caterpillar. Very different structure. They contain different elements, okay? So it makes a big difference. Why are diamond and sugar very different? Well, they both are white and looks crystally. Well, okay, no, you're not gonna eat a diamond. You could eat a sugar though, for very distinct reasons. Look at the composition, look at the structure, okay? So we're gonna go ahead and now talk about an element. Well, what is an element? An element is a pure substance. Okay, so it's not a mixture, it's not dirty or, something like that. All right, it's a pure substance, we'll talk more about that later, that cannot be broken down into simpler, stable substances, and it's made up of only one type of an element. All right, that is the key. It's made up of one type of element. It cannot be broken down, and it's made up of one type of element. So which one of my two examples from here, the diamond or the sucrose, which one is elemental? All right, hopefully you figured out it is the diamond. Why? They're all carbon atoms, okay? You really can't break down a diamond into simpler substances. You can cut it and break it up and make, different patterns out of it, sure. All right, but you're not breaking it actually down into a simpler substance. It already is in its simpler substance, okay? It's already carbon. The idea of a compound, it has more than one type of element, so it doesn't fit that definition. So what about demo day? All right, what about demo day? Well, go back. What was the very first one we did? Hey, let's go look. All right, what was the very first demo we did? Do you remember this? We have magnesium and oxygen. All right, we had that bright, bright, bright light coming out of that. All right, so which one would I have from my definition? Which one's an element? All right, it would be magnesium or oxygen, or maybe both. Trick question. All right, and so let's see what our answer is. And the answer is magnesium, okay? I will talk about oxygen in a little bit, okay? But magnesium would be the classic definition of the element, all right? So how would I show that magnesium wire, if you will, that we used, all right, in particles, all right? I have them like in little circles, kind of close to each other, all right? That would be my magnesium. Notice that they're all the same particle. Okay, well, what's a compound? Okay, is a substance that can be broken down into simple, stable substances. Each compound is made of atoms of two or more. Aha, that's your key definition right here. Two or more what? Different elements that are chemically bonded. All right, so that's your biggest difference between an element and a compound is you have the same element for the same atom for an element, you have different atoms for a compound. So which of my example up above, all right, probably not a difficult question here, which one of these two would be a compound? Well, hopefully you picked sucrose. That's right. All right, it is sucrose. Why? Because it has carbon, hydrogen, oxygen chemically bound together. All right, so what about the demo day? Well, go back and let's look at demo day the third. Let's use this one. All right, there's a reason why. We had methane and oxygen, O2 again. And so which one of those two would be my compound, methane or oxygen? Well, hopefully you all picked methane, and you're right. So my formula for methane is CH4. So how would I show this using a particle? All right. I would have my carbon is the black in the middle, and then my hydrogen is kind of that, I don't know, orangey one on the sides there, okay? And I kind of referred to oxygen earlier, but what about oxygen? Is it an element or a compound? It doesn't perfectly fit either definition, but what do you think it's closer to? Is it closer to an element's definition or closer to the compound? It's definitely much closer to an element definition, all right? You have the same O's in there, all right? But what's different about it, all right? Magnesium can exist as one atom of magnesium, okay? Gold can exist as one atom of gold. Carbon can exist as one atom of carbon, okay? That is its simplest form. Let's go back up there again. That's its simplest form, all right? O2, look at that, it's O2. You can break O2 apart. You have to break O2 apart to get to the simplest substance, all right? So you can break O2 down. So it's not a perfect definition of an element. So there has to be something else, all right? We call it a diatomic element. Very, very clever. If you look at the words diatomic, two-atomed element, all right, is a pure substance made up of two of the what? Of the same atoms chemically combined, all right? So that we can, make sense of why does O2 exist? Why does H2 exist, all right? They're called diatomic elements, all right? Most of the elements on the periodic table are not diatomic. There's only 7 of them that are, and all the other ones can exist as a single atom. The 7, which is hydrogen H2, oxygen O2, and fluorine, chlorine, bromine, iodine, and nitrogen. Those are going to be your diatomics. We'll talk more about those later. Okay, and that concludes section 1.2.1. And I hope this was helpful. If you have any questions, you can always watch the video again, or ask questions in class to your teacher. And don't forget, this is a shorter video. Why? Because there'll be an objective check over just this topic, all right, shortly following. All right, well, I'm going to leave you this thought. Don't wait to be great. See you next time. Bye-bye.